every single second of the day, there's this silent, high-stakes battle being fought inside your body. And it's not against some virus or bacteria, nope, it's against chemistry itself. It's this constant, incredible struggle to maintain a perfect, delicate balance. So let's pull back the curtain on this amazing internal balancing act. I mean, think about it. Your metabolism, the very thing that keeps you alive, is constantly just churning out acid. So what's the secret? What incredible system of checks and balances stops your body from, well, basically dissolving from the inside out? That's the mystery we're going to unravel today. To really get this, you first have to appreciate just how fine a line our body walks every moment. We are literally talking about life on a chemical razor's edge. The difference between being healthy and total catastrophe is almost invisibly small. And this is it. This is the magic number. The pH of your blood has to stay right around 7.4. If it shifts by just a few tenths of a point in either direction for too long, your body's most critical functions, like how your enzymes work, they just start to shut down. This number is not a suggestion, it is a non-negotiable rule for survival. Okay, this probably throws you right back to high school chemistry class, right? The pH scale is just a way to measure how acidic or alkaline something is. So an acidic solution, which is full of hydrogen ions, turns that little litmus paper red. An alkaline, or basic solution, does the opposite, turning it blue. And our blood, at 7.4, is sitting right in that perfect, slightly alkaline sweet spot. So if 7.4 is the goal, what's always trying to mess it up? All right, let's meet the antagonists in our body's daily drama, the acids. In simple terms, an acid is just a molecule that loves to give away a hydrogen ion. And that little H+ ion, that's the villain of our story. The more of these guys you have floating around, the more acidic things get, and the more danger your body is in. Now, our body makes two main kinds of these acid threats. First, you've got your volatile acid. This is basically just the carbon dioxide from your everyday metabolism. We make a ton of it, but luckily we can just breathe it out. Easy enough. But then you have the fixed acids. These are the tougher customers, like sulfuric and lactic acid. They come from breaking down proteins or from really intense exercise. You can't breathe these out. They have to be dealt with by the kidneys. So with all these acids popping up all the time, how does the body fight back? Well, it starts with the first responders, an instantaneous chemical defense system that's always on patrol. The best way to think of a buffer is as a chemical shock absorber. Its entire job is to soak up those dangerous extra hydrogen ions before they have a chance to mess with the blood's pH. It's a really elegant and, most importantly, immediate solution to prevent total chaos. So, the most important buffer system in our blood is the bicarbonate system, and it works in a flash. Here's how. A strong, dangerous acid shows up. The bicarbonate buffer immediately jumps in and intercepts it, and through this super fast reaction, the threat is totally neutralized. It's converted into some harmless salt and a very weak acid that the body can easily handle. It's just a beautiful, efficient piece of chemical self-defense. But you know, buffers are just the first line of defense. They can get overwhelmed. So when the acid load gets too high, the body has to call in the heavy hitters, the powerful organ systems that are there to maintain long-term order. Let's meet the rest of the defense team. First up, you've got the lungs. Think of them as the rapid response team. Within minutes of sensing a pH change, they can adjust your breathing. Too much acid, you'll start to breathe faster and deeper to blow off more CO2. Then you have the kidneys. They're the long-term engineers. They work a lot slower, over hours or even days, but wow, are they powerful. They physically remove those tough, fixed acids from the body in urine, and they can reclaim that precious bicarbonate buffer to restock the body's defenses. So we've got buffers, we've got lungs, we've got kidneys, all working together in harmony. But what happens when this incredibly intricate system is pushed past its limits? What happens when the balance finally breaks? When the whole system goes haywire, it usually falls into one of these four states. If the problem is with acid or bicarbonate levels, we call it metabolic acidosis or alkalosis. For instance, losing too much bicarbonate from diarrhea can cause acidosis. Now, if the problem is with the lungs' ability to handle CO2, it's called respiratory acidosis or alkalosis. And as you can see, each has a pretty distinct cause, from an airway obstruction to something as simple as hyperventilating. Figuring out if the problem is metabolic or respiratory is the very first step to fixing it. Let's zoom in on metabolic acidosis for a sec. To get to the root cause, doctors use this really clever diagnostic tool called the anion gap. Now, it sounds complicated, but in short, they measure the positive and negative ions in your blood. If there's a gap, meaning more unmeasured negative ions than they expect, it points to a pretty specific list of culprits. This anion gap is usually caused by a buildup of some kind of hidden acids. And to remember the most common ones, clinicians have this fantastic mnemonic, mud piles. Each letter stands for a different cause. So, for example, the D can stand for diabetic ketoacidosis, where the body makes acidic ketones. Or the L can be for lactic acidosis, like after super intense exercise. It's a really powerful tool that helps doctors quickly narrow down where the problem is coming from. So, we've seen this incredible, totally automated system of buffers in lungs and kidneys that fights this silent battle for you every single moment of your life. And it kind of leaves us with the critical question, doesn't it? In our world of processed foods and stress and extreme diets, are we actually respecting this delicate balance? Or are we pushing this ancient, elegant system right to its breaking point?